Hey guys, it's Max and we're back with Battlecode 2016. In this episode, I'll show you how to use the attacking code. Okay, so we're back here in robotplayer.java. We have our code that moves together the two robot teams. In Battlecode, you have to choose between moving and attacking. You can't do both at the same time. So what we'll do is we'll check to see if there are any enemies nearby, and on the basis of that, we'll decide whether to move or to attack them. Okay, so here where we've got rc.isCoreReady, this is the main piece of the code that runs over and over again. So let's start to make things a little easier to read. We'll call this repeat. Okay, this is a function we're defining called repeat, and it's what's going to happen repeatedly, ideally. It's surrounded by try-catch, so whatever happens in it, if there's a mistake or there's an exception, the catch code will run, and then it'll get to the end here, and then it'll go back to the beginning, and it'll repeat again. And after each repeat, we're going to call rc.yield. Yield ends the current turn, and it means that we won't be using all of our compute power cycling repeatedly in the middle of the turn. Okay, I think it's actually changed to clock.yield this year. Okay, and then we'll make our method called repeat, public static void repeat. You'll note that, oh, what's this here? Unreachable catch block. The exception is never thrown. Aha! Throws game action exception. And now there's no problem. And look, there's a problem that RC, this variable here, which was passed into run via this argument, is no longer available in repeat. If this is your first time with Java, then you're seeing that that your variables are not always accessible everywhere. I have moving direction. That's accessible here in this function because it was defined back here, but think of it like this way. This one was defined inside these curly brackets, and so it's not available over here. It's almost like maybe you live in Australia or something, and maybe certain movie releases happen at a different time. That's a terrible analogy. Let's say certain brands of chocolate are not available there. Well, more realistically, they have the brands of chocolate there that are not available here in the United States. Okay, now that I've thoroughly confused everybody, let's fix the problem. So we'll make a variable out here so that everybody can use it. We'll call it, it's got, the type of it is robot controller, and I like RC, so I'm about to do something that makes no sense at all. Okay, so I want to set the outer variable RC equal to what it was defined inside, but this is nonsense, this little piece here. It's because it gets confused about which RC I'm talking about. So I'll call this RC in. It's like it's coming in, and then I'm catching it, and now I'm making it available to everyone. I'm distributing the chocolate around the entire world. Okay, same brand of chocolate, global distribution. This makes no sense, does it? Okay, so under repeat, I'm going to check if the core is ready. But remember, this, the whole point of this was for attacking and for combat and for excitement. Okay, so let's look for enemies, and we'll move depending on whether we see enemies. This year, enemies appear when you retrieve them as an array of robot info. So robot info, we'll call them zombie enemies, equals rc.sense nearby robots. And look, there's several of these functions here. One of them doesn't take any arguments at all, and it just finds all the nearby robots on all teams. But we don't want to shoot at allies, so we should specify the team, and we should specify the distance as well. So we'll specify the distance as rc.getType.attack radius squared. So it's only going to look for robots that are within my attack radius. And if I can't attack them, I might as well start moving and continue moving anyway, and hopefully I'll get closer to them. Then I can attack them. And we'll do rc, we'll do team.zombie. Now there's kind of a problem here. I'm only going to be able to attack zombies, but for now, let's just leave it at that. So we need to see if this list, you see, it's the type of this variable is robot info, and the open close brackets means that it's a list. So it may have 0 entries in it, and that would be a list of length 0. So we need to check if there's more than 0 entries. Zombie enemies dot length is greater than 0. So if there are enemies, then I should shoot at them, and otherwise I will do this part of the code. So here's else, and else is the piece of the code that will operate if this isn't true. We're sort of assuming that you have a basic understanding of flow control in other languages perhaps, so you can just read on how these things work online if you don't get this. You might ask, what's the point of me then if I'm supposed to be explaining this? Well, I don't know what the point of me is. Don't ask me that, okay? Okay, so if the length is greater than 0, let's attack one of them. I don't really care which one we attack. So let's just do if rc.isWeaponReady, then we'll just attack it. rc.attack location. Attack always takes a location rather than a robot in particular, because there's a chance that your code will be interrupted or something will take place and the robot will move, and then you won't be able to attack it. Just attack the location. It's safer, and you'll hit whatever's there. Okay, that was our thinking when we were designing the code. So attack the location, and we will attack that location where the enemy is. So we have to take the first, say we know there's more than 0 entries in that list. Well, let's just take the 0th entry, the first entry. Zombie enemies at 0. So if I use open square brackets like this with a number inside, that gets one of the items out of the list, and the 0th item is the first item, and we know there is a 0th item in the list because the length of that list is greater than 0. Say the length is 1, then there is a 0th item and there's no first item. The numbers start at 0, okay, in Java. That's how it works. Oh, I'm just a wealth of useful information, aren't I? Okay, so well, attack that location. So we have the robot info, and now we extract from the info the location. So I just put a dot, and that'll get me all the properties of that robot info, and one of those properties is location. So zombie enemies dot location. You saw some other properties there. So we're going to attack that location if our weapon is ready. Otherwise, we're going to move. Okay? So like this, I should be able to save and run the code. And now it's even going to be better performance on my computer, because instead of repeating this 1,000 times in every round, it's only going to do this, call this repeat function once per round, because it'll do whatever's in here. It'll exit this method because there's no while loop. It just comes to the top, starts, goes to the bottom. It finishes this, and then it yields. And then when it's done yielding, if it had no error, it skips the catch block, and it goes back to the beginning, and then it goes back to here on the next round. So you're going to see probably slightly better performance from this piece of code. If you have any questions about how the code runs, too bad, because all these lecture videos are pre-recorded. No, I'm just kidding. You can put them in the comments down below, or you can report them on our forum, or you can ask your friends, or you can guess what the solution is, or you can download this code and play with it. Go ahead, delete pieces of it, and see what happens. Most of the time, you're going to see that there's going to be some kind of error, and it's going to show up in the console. If you run from Eclipse here, it's going to show up in the console down here. And if you run from ant-run using git shell, like from here, then you're going to see errors in the console here. And yeah, a lot of it's not human readable, but some of it is. You know, like look here, caused by this unit cannot move. You know, you can figure that out, and you can guess your way through it, and you can ask your friends, and eventually you might get it. So let's do this. I'm going to run the match, and we're going to see if our guys attack the zombies. We're seeing lots of errors, but are we attacking zombies? Look at that. Look at that. Our turrets. They're attacking this dude. They're attacking them. It's very exciting. Also, the match is running nice and slow. I'm wondering if I'm dropping frames. But you know what I am dropping is a sick beat. a sick beat. This is exciting and very effective. So you see the Archons, they're not attacking because they can't attack. We got everybody on the team. They're all working together. This is like something you'll never see in a real Battlecode game. This red and blue team working together to fight the zombies, because they're not programmed to attack one another. You see these two guys, they're right next to one another, but they're not attacking each other because I'm only looking for team.zombie. So in the next one, maybe we'll see what to do about attacking the zombies as well. I think my computer is having a lot of trouble. But look here, each of these robots, when I select the robot, I can look at the byte codes used at the top, and it says only 123. So if you were astute and very carefully looking at the previous video, when I click on a robot, it was using its maximum bytecode, but now it's using much less because it's yielding its turn at the end of its computation instead of repeating the same computation over and over again. The way that would have looked is it would try to move forward, and maybe it would succeed the first time, and then the subsequent 200 times it would fail because it's already moved this turn, and so it would have a core delay. Okay, so with this attacking, we've done a pretty good job against the enemy. I'm not sure whether we're going to come out on top. It's not clear, and part of the reason might be that we've got guys which are not participating in the fight. They're not really doing a good job. Like say this guy. Robots can move diagonally in Battlecode, and this guy could totally move diagonally and start to help out, but he's currently blocked and he's not moving smart. So in the next video, we'll try to make our players move more smart. Yeah, good talking, Max. And then we'll see if we can do a little better against these guys. Okay, so see you next time. Bye bye.